All right, welcome back. Another episode of Season 3 with the SEEK Bytes engineering podcast for engineers by engineers. Today we're going to be talking a little bit about something I like to call PERL. You might know it by different acronyms. We'll get into it in a little bit. But I'm joined here today with Elliot and Will.
Hello.
Hello.
Today's topic is what I'm calling PERL. This is not my own idea. This is just an easier acronym that I've come up with to help memorize this, because the readings that I've done on this, I can never remember the acronyms. But essentially what PERL is plan, execute, review, and learn. And what this is a kind of a methodology for using AI agents and getting the benefits out of them while also feeding back the learnings that you get from them back into what we call back pressure. So we'll talk a little bit about back pressure in a moment. But I'm curious what you two have been doing with your agents. How have you two been using agents? What's your kind of methodology? Do you have a methodology? Because what I've seen, at least from like the mid-junior engineers that I've been working with, a lot of them are just doing one-shots where they're in agent mode. They're maybe not even thinking about the agent that they're using, like the model that they're using. They've just got the model set to default. They've got their IDE set to agent mode, and they're just throwing in a single prompt and hoping for the best.
Yeah, really great question. So in terms of how I'm using it, there's a couple of different use cases. So I'm getting it to do some planning and kind of analysis because I'm like, I want you to come up with information about something. So an example I used the other day was I wanted to replace an API endpoint with a new one. And so I said, I want you to come up with a plan based on the data you can see flowing through the system and the existing types. I want you to come up with a plan for a new endpoint to handle the same use case, but removing all redundant fields. And so it kind of went through and I was like, great. So it came up with a really good plan. That was really, really useful. Another use case was actually off the back of something that Seamus did. So we do a quarterly kind of tech health analysis of our different systems to track speed and agility, the supportability and whatnot. And some of that takes into account purely what's in the code base, different RFCs and whatnot, but also external factors that aren't visible to code, such as like, do we have enough staff to support this who know the kind of system? Is it documented well? Stuff like that. And Seamus put together a skill that I was able to use on a bunch of different systems to try and get information, which was really useful. Again, it was supplementary to what I was doing. So I didn't just kind of take it and dump it in there. I'd already gone and done one, but I was like, I wanted supplementary information to support the argument that I was kind of making for various levels.
Yeah, nice. I did actually follow PERL when I was doing that skill. It was kind of my proof of concept. It was kind of me forcing myself to follow this process and actually getting concrete learnings for myself around how valuable it is to follow a process and not just do one-shot things. But before we go into talking about that skill and how I used PERL to build that skill and improve it, I'm curious with your the planning that you did with that agent before, was that just switch to plan mode and just one shot, like you gave it a single prompt, or were you going back and forth with it on making the plan?
I actually did two. So I did one that was probably more of the P&E of PERL, where I just said, do this, and I hadn't changed it to plan mode. So it did the plan, and then it immediately started executing. It was following a pretty reasonable plan, but I was like, I don't actually need you to execute because we don't need it now, but I was like, I want the plan. So I did that and I viewed what it came out was, and I kind of like stored that away in working memory. I was like, okay. And then I was like, so delete all that, undo everything you've just done, reset to master. Now do it in plan mode. So when we talk about PERL, I've probably been doing more of the PE bit.
Yeah, I was
There hasn't been that review or that learning. There hasn't been the like tailoring what it's come back with. It's just been like, no, I need you to do a thing. You've done the thing, and I will then take it from there.
Yeah, I think what I've seen, and I've heard, and I've watched interviews with Google engineers and Amazon engineers talking about not this acronym but these concepts. And one thing that I saw one of them talking about recently, which I found very accurate to what I've been seeing at SEEK, there's kind of levels of AI usage. Level 0 being you don't use it at all. Level 1 being prompting, like just Copilot helping you finish a single sentence. Level 2 is probably when you just do execute. You're just doing one shots and you're constantly on agent mode. You're always just using the default model and you're just trying to just do a single task at a time. I think like level 3 is probably what you're talking about, where you separate the planning and the execution. Maybe you level up a little bit by switching the model as well. So not only switching plan mode, but you're specifically choosing high reasoning like Opus 4.6 to produce the best plan, switching down to a faster, cheaper model like Composer 2 or Codex 5.3 or something to do the execute step. And then the next level up, like level 4, level 5, is where you're looking at introducing review and learn. And I think the review and learn, like switching out plan and execute, like moving from one shot to separating plan and execution, I think is a huge step up for the majority of engineers. But what I'm finding is to really have that 10x value is when you introduce review and learn, and that's where you're actually using the agent to review mistakes that it made and then taking those mistakes. That's just the review step, right? And you don't have to do the learn step. And I think this is where I see some people starting to step into the R&L, the review and learn phase, maybe not doing the learn part, and I'll get to that in a sec. And the reviewing is basically just putting learning into their own head so that the next time they do a prompt, they're aware of the failures or the gaps in the prompting and what they need to do to make the prompt better and get the behavior to be more consistent. The learn step is where you're actually taking the results from your review step and feeding it back into back pressure. So I mentioned back pressure before, and I've mentioned it on previous episodes, but it's good to review this concept in case people aren't familiar with it or they haven't listened to another episode. Back pressure is like unit tests, component tests, even documentation, and this is something I hadn't considered at first, is you have like ADRs, which are your architecture decision registry. So that, like our systems follow clean architecture, our logging follows this standardization, our, TORM things, basically any documented decisions around your architecture, right? So you put that into your code base and it helps your agent understand how to write code that aligns with your code base. And then there's also like product decision PRDs, what are they called? Product requirements document. Yeah, PRDs. Yeah. So PRDs, product requirement documents, ADRs, your architectural decision register, as well as unit tests, component tests, and rules and skills. We've already talked about rules and skills before. I think most people familiar with agents have probably heard those concepts before. And that's where I think the value from following this process really amplifies. Because the learning step is then baked in for every other engineer in your team. It's not just you getting the learnings and you're getting better, but you're helping other people get better and produce more, not deterministic, but more consistent results out of the agent. I think Elliot and I have talked a bit. I'm curious, Will, have you been following any of these kinds of processes? Have you been just doing one-shots? What's your method for using agents?
Yeah, probably the same as kind of what Elliot's doing. I've been trying to – I did try out plan mode the other day. I bumped it up on to Opus Max, and that was the first time I've ever done that. So I'm like, am I going to use all my credits from this one prompt?
Yeah.
And yeah, after it made a plan, I didn't realize you could save a plan as well, because otherwise it executes it and just like throws it away. I didn't realize you could save it. So I saved it and just got the standard model to execute on it. This was just for a prototypes thing. So I committed both the plan it created and just what it output just into a branch and just to kind of document it later. Yeah, nice. But I thought that was cool. So certainly something I want to try and do more of, but I'm definitely curious about the review part of how, because there's no review option, is there?
There is an ask option. So
there is, yeah.
Yeah, it is interesting. Like I haven't used ask too much until now, but I have been using it as part of the review step. Because plan, so to give a little bit of context, the cursor or whatever IDE, OpenClaw, whatever tool you're using that wraps the model, it's a harness. And there's lots of different kinds of harnesses. And it's essentially the programmatic wrapper around the model that kind of forces it to respond in a certain way. So when you do agent mode or plan mode or ask mode, this is my understanding, could be not accurate, but I believe this is correct, is you're changing the harness, behavior of the harness itself. So in plan mode, what's happening is your prompt is going to the agent is responding, and then the plan harness is kind of coercing the agent to continue on a loop. And these harnesses are basically, all it is just like a for loop with some conditions that are forcing the agent, once these conditions are met, the harness has been achieved, like the desire of the harness has been achieved, and I can now return the response back to the user. So in plan mode, again, because I haven't looked at the nuts and bolts and dug into the actual code, I'm not sure if I doubt Cursor is open source. Maybe it is, I don't know. But basically I haven't dug into the actual code, but I understand exactly how harnesses work. And so when you switch into plan or agent mode or ask mode, you're essentially giving it a different set of rules that it has to abide by to be done, whatever done looks like. So ask mode doesn't try to produce a document. It just tries to answer your question. So I find ask really helpful for when you're kind of wanting to do a bit of back and forth. And in fact, I actually have a skill that I grabbed off someone online. It's a really simple, like 4-line prompt, and it's called grill me. So I do /grill me, and it kind of forces the agent to not just accept what I'm asking it to do, but to question what it is that I want to do, which is I find really helpful for the review step. So I might go plan with Opus 4.6, produce a good plan, but I'll do grill me on the plan as well. So I won't just say, hey, for Elliot's thing, for example, I'm trying to replace an endpoint, I'm trying to refactor something. And usually plan mode, it'll just go ahead, start to iterate, and then you'll see the loop starting to happen. You'll see the chat go, it's thinking, doing something, thinking, doing something. And
that was actually part of what I'm still getting used to is sometimes that can take a while to actually plan. And
it might go off the rails, right?
Yeah.
Maybe not off the rails. I find plan mode with Opus tends to not go too far off the rails, but you have to wait a while and you're using a lot of tokens. And then you find in the plan, oh, actually there's some bits I forgot to tell you about. So what I've been doing with plan mode is doing /grill me, this skill, which I wouldn't suggest copying the one that I have because it is so simple. I would just say, ask your agent to make a skill called grill me, and then basically just tell it, I want you to question everything until we reach a point of a consensus before you begin making plans. That's the grill me skill.
Yeah, don't treat me like a burger skill. It's not that.
Yeah, so I basically just switch to plan mode, switch to Opus 4.6 on Macs. I'll do /grill me, and that way it won't start absorbing all my tokens in the most expensive model I have available to until we've come to a consensus as to what the plan should be doing. Then it'll go ahead and it'll make the plan. And I find that really valuable for reducing token consumption. Because when I was making that tech health assessment skill, I went through 10% of my monthly allotment in a single prompt.
When I was doing that plan for that API endpoint, I burnt through, with those 2 prompts, burnt through the entire token allotment that I had. And I was just like, well, that's unfortunate and unexpected, because I was basically trying to try out the PERL thing that you kind of talked about. But I think what you two have both highlighted is that, yes, sometimes the agents can take a really long time back and forth with itself. I think where I'm kind of missing the really 10x level from the agent usage is being able to have a UI or something that allows me to kind of like pair agents together. So we talked about OpenClaw on a previous episode, and where there's kind of a UI for like, here's the orchestrator and here's the planner and here's the this. What I kind of want to be able to do, and I suspect we will get there, we're just not quite there yet with, say, Cursor and other tools, is that to be able to say, I want to do a task, and for this task, I need someone to go ahead and plan. Then I need someone to execute. Then I need something to review it. And you kind of want the plan step to go and do its thing, but then the execution and the review need to go back and forth until the plan has been met and until the reviewer is satisfied. And I think once the average engineer can kind of leverage that without having to do a lot of setup, I think that's where we're really going to see some massive productivity improvements, because you will be able to say, look, here is the plan that I've approved. You've gone through it. You've high level structured it. You're like, this looks good. This is what I could give to an engineer, from junior to staff or above, and they would go off and do whatever level job. The execution bit is obviously hit and miss with agents. Some agents, depending on the model and whatnot, and depending on the complexity of the task, may do it really, really well. And depending on that kind of harness that they have, if they're checking that to-do list. But then the review step, I think, is just so critical, because what I've seen with some of the executions is they will get the task done. But if you then ask it to review its own code, it will be like, oh, you shouldn't do this. This is not best practice, or this could be better, or this could be better. And I think that just review step is so critical, but I want the execute and review to be in a loop, but I don't want it to be a loop that can just run infinitely, because I've seen it kind of happen in plan mode or agent mode. Sometimes you ask it to do a thing and it literally just goes back and forth between 2 different implementation options. And if you're not paying attention, it's like, you tried that, it didn't work. You went back to the thing before, and then you tried the thing that just didn't work again. And I'm like, no, you need to stop now.
Yeah, that's kind of like, I don't know what they would call this. I would call it like a harness failure. It's essentially like the model is struggling to achieve the stop condition for the harness. And so the harness is forcing it back into thinking. And it's not producing the right structured output that tells the harness, I'm done now. And so it just keeps going, stop, continue, stop, continue, stop, continue. And that's where you can fall into these loops where you just start absorbing tokens accidentally. I think one thing that I want to call out is you mentioned about review. There's kind of two different reviews. There's the actual code review where you can review the code that it implemented or whatever it's done and surface mistakes or issues with it. I think that's like excellent. It's surprisingly good at picking out really nitty-gritty details that I often would just not think about or completely overlook in the context of a big PR with lots of changes. But the review step is also about, and I think primarily about, digging out the mistakes. I guess it's still kind of the same thing. I think it's less about the mistakes in the code and more about the mistakes in the behavior that the agent went through. And that's where the learning step comes in. It's kind of both valid. I guess it's two different kinds of review. There's the reviewing the behavior of the conversation, and maybe it went too fast, too quickly, it went too planned, too deeply. You're kind of trying to analyze the behavior of the agent so that you can bake in rules, skills, and other back pressure that's going to like stop that from happening again. So I guess what you're saying is right too. It's just a different flavor of what I was thinking about. When I think about the review step, when I think about the execute step, that includes what you're talking about for the review. It's like I'm executing and then I'm doing a code review to make sure that I'm satisfied with the code. And then when I'm going into the review step of PERL, that's more about me having a conversation with the agent and saying, what did we get wrong? What could we do to improve token consumption? What could we do to improve back pressure so you don't make those mistakes again? It's kind of like a second planning step. And then once you've kind of figured out through that conversation with the agent what you could improve if you were to do this prompt again, like how could we get to where we are now with less effort if we were to do this again? And the agent will often surface a lot of really valuable insights on maybe the prompt could have been a little bit more accurate, or if you'd have included this IAC or this RFC repo or something, then I wouldn't have made this mistake in the first place. I wouldn't have made that assumption in the first place. And looking at the skill, the tech health skill, that's kind of what I did. Was it surfaced that we didn't have RFCs in the code base, we didn't have IAC in the code base, we didn't have monitoring in the code base. And so through that conversation, it surfaced, hey, if you'd have mentioned that IAC was in a different repo, I wouldn't have said your repo is lacking IAC or it's lacking monitoring. And you're also talking about the kind of going review and execute as a loop and separating these two agents. What I did, it's not quite the same thing, but I feel like it relates. What I ended up doing through this review and learn process is I identified that having a single agent do the entire assessment meant that when it was looking at security or supportability or each of the pillars, or in our health assessment, we have different pillars, it has the entire context of what it's assessing. And it occurred to me that you'd actually get better results by isolating each pillar into a sub-agent. And this is very simple, and it all just happens under the hood. So in that review step, it identified that, hey, maybe if we isolated each agent, we could get much more specific feedback. Like I could get security. I'm just thinking about security. And so in the learn step, I said, all right, cool. Let's go ahead. I want you to update the skill so that when reviewing each pillar, you spawn sub-agents that have a copy of the current context. So those agents don't go back in and dig up all the context file information. It's basically Opus begins as the orchestrator, which is what we're talking about in the other episode about OpenClaw. So Opus is acting as the orchestrator. It's grabbing all the context, so it's just happening once. Then it spawns 5 sub-agents to do each pillar and passes the context into those ones there. They have their own context windows, so it is going to consume more tokens, but less tokens than if it went and grabbed all the information again, because the agent, the initial agent, the orchestrator is going to provide essentially like summarized context. It's going to be like a cleaner context for it.
I don't think it's a review. I think it's a retrospective.
Yes.
So, because when you hear review, you're thinking code review, right? And I think you've probably hit the nail on the head. Is that if you're doing PERL, you've got the plan, you've got the execute. The execute phase does not finish until you've reviewed the thing and you're happy with the output. So really, that the review step it's the retrospective step.
One thing I will call out, I don't know if we've talked about it much before, but it's context compaction. So I think people are going to start to hit a problem that they might not have experienced in the past. Because we're introducing so many layers, so many steps, and you might not be creating a new chat for each of these steps, which is something else that I recommend. If you're being cautious of context compaction, I'll explain context compaction in a second. One thing you can do is actually switch to it, because Will mentioned before that when you do plan mode, it'll save your plan. What I really like about that is I can make a totally brand new chat with a totally brand new context window, and the only context is the plan. So I now am like reducing the chance of hitting context compaction. So let's talk about what compaction is. Compaction is essentially when you hit your token limit, say it's 200K, 150K, depends on the model that you're using. the agent will try, because it's not just going to fall over and stop when it runs out of tokens. What it'll do is it'll take your entire context history and it'll try to compress it down. We did talk about this in one of the other episodes. Try to compress it down and strip away redundant information. So let's say you're doing /grill me, you're going back and forth. It's going to remove the back and forth. It's going to remove what you said each time because it's no longer relevant. All it cares about is what the final output was. And in that process, it can actually strip away relevant context by mistake. And that's kind of where I've seen hallucinations start to kick in. So if you're going to follow PERL, pro tip, be cautious of context compaction. Try to maybe switch chats if you're finding that you're starting to reach, or maybe just between the plan and the execute step. I haven't tried switching to a new chat when you go into review and learn because I don't know how you would get the maybe you could save a file, like you could tell it to export content. I don't think that would even work because it's going to be the entire size of the context. So pretty much like the plan, which I think is probably one of the heaviest steps, you could isolate that one and then the rest of it you're doing a new chat.
I do wonder if you could isolate some of the execute step, but I also wonder if it's a skill that you could potentially make to be like, I need you to create a summary of what you did under the hood so we can improve upon it and output that, as opposed to trying to keep the entire context.
Can I want to dig a little bit more into the review and learn part because I'm still a little vague on how that, like what prompts are you getting as saying for it to review? And you even said these are things that your team and the rest of the code can kind of learn from as well. How are you doing that review and learn phase? What are like some even specific examples that you actually prompting it?
Yeah, okay. So,
and you said this is mostly in ask mode or something that this is happening in?
I've only just started doing it in ask mode.
Okay.
Yeah, because I don't want to produce a plan necessarily, and I don't want it to go and do things, but it'll work in agent mode depending on what you prompt it. It's either because agent mode, I feel like it's going to try and make change to stuff, but it won't always. It depends on the question that you're asking it. But when you put it in ask mode, it actually has access to less MCPs, less skills. Like the harness essentially changes what it can and can't do. To answer your question, it's actually it's not really that complicated. It's pretty much just, I've done my execute.
I'm just a big dum-dum then.
No. Here's the thing is when I first read about this and people were, Google engineers and Amazon engineers were kind of revealing a similar process to follow, I was in the same boat. I was like, what does this look like? What does it actually look like?
Yeah.
And then when I did it with a skill, I was like, oh, it's really not that complicated. It's pretty much just a conversation with the agent to surf. And here's the thing is I realized more and more that it's not really anything you're doing. It's providing the opportunity for the agent to analyze its own behavior, really. It's just a conversation that I'm having with the agent and I'm saying, what are some opportunities from this context, from this thread that you can identify to build back pressure from and improve? And generally, its output is pretty good without me having to do it. But if I identify things myself, I can add those in as well. And that's usually where the learn step comes in. So if I might skip the review step entirely. If I know 2 or 3, like I'm going through PERL and I'm going back and over, and I'm looping over the entire flow over and over again, I might identify things that I know. So there's a couple of things that I got from the learning and from the review step. One of them was the sub-agent process, which was just not convoluting each pillar's review. And that was basically just, hey, what could you do to improve? And it was surfacing, if you use sub-agents, we could ensure that the context for each pillar is as clean as possible. It's only considering security concerns. So it's not looking at code quality. It's not looking at those concerns. It's just looking at security things. It's looking at your package dependencies. It's looking at SNCC. And I didn't even tell it to look at SNCC. So when I switched it into sub-agent, that sub-agent started considering the SNCC MCP and actually going out and looking at our real critical vulnerabilities to identify, you've got 158, high-level vulnerabilities or however many vulnerabilities. So again, it can be things that you identify just through the conversation during the plan and execute steps. It's often things that the agent kind of surfaces for itself just through using that ask mode and saying, what do you think you could improve next time? And I think the learn step, so the review step I think is not that complicated. It's the learn step where I think people need to actually practice this to understand how to do that. And that pretty much comes down to like identifying what the level of scope the learnings can improve. And that might be an organization level. It might be a team level. It might be a personal level. And understanding the difference between skills or rules that are defined in your code base that the team shares, skills or rules that are defined in your local configuration that no one else has access to, or organization level harnesses. And this is where things like a centralized MCP gateway come in. So at SEEK, we have a centralized LLM gateway, we have a centralized MCP gateway, and those things control access to all these external tools. So that's like the organization level controls, right? So for the learning step at an org level, what I've been doing is I've been reaching out to the engineering manager from our developer experience team who own the skills toolkit and sort of feeding back into them. Something I think that would be good would be versioning skills. So when skills perform poorly in the future, we can identify that a regression occurred because when you've used the assessment, it'll say, I used this model, the skill was this version, and we can identify, hey, if someone gives us feedback and says, I tried using this skill, it's given me really bad results, we can then go and say, oh, that's because you're on this version. All right, we've noticed a regression. Have a look at the prompt, do a diff against the previous iterations of the prompt and say, oh, the agent actually compacted the context of the skill and removed some really critical rules that I put in there manually myself. So when I say it's like not that complicated, I say it's not complicated because I'm not actually doing anything. The agent's doing all the work.
At least for the review side. But you're saying, it sounds like you're saying the learn side is more what are we learning from what the output that the agent has done, right?
And this is where I think the main way that I've been baking in the learnings to kind of solve these problems is through skills and rules. And one thing to call out is that with rules, there's no guarantee the agent actually does pull them in. It'll do a scan over the rule set and try to identify relevant rules to the prompt, but it might not pick up the rule that is relevant. This is where I find skills better because you're running the skill. It's not deterministic, but it's more deterministic than rules.
Yeah, I found sometimes it pulls in the rule and then it just flat out ignores them.
Yeah, that was really fascinating. I mean, there's definitely, I feel like I've started doing the first part of PERL, the P and the E, but the R and the L, it was really interesting to learn a little bit more about that.
So you're
and how
probably
I
on the lower end of the AI usage then, maybe at level 1, level 2.
Oh, definitely. I mean, Shema was saying I'm getting the AI to create sub-agents. I'm like, I didn't even know I could tell it to do that.
Well,
like,
that's what I'm hearing. And when I heard that, I was like, had I known that, I would have done things so differently.
Have you ever run a prompt and you see multiple bubbles? Mm-hmm. Those are all sub-agents. So when you see it like spawn a bubble, spawn a bubble, spawn a bubble, and all three of them have a wheel spinning, those are sub-agents. It's just doing it on behalf. It's like, it's kind of intelligently figuring out, you know what? These things are three discrete things that I'm trying to solve. I'm just going to spawn different sub-agents to do that work.
Mm-hmm.
Yeah.
Makes sense.
Yeah. Because I'm using PERL and the process, because I'm not doing a one-shot, right? I'm not just throwing in a prompt and then I'm getting a response pretty almost instantly, right? Like it's starting to write code and I'm watching it write the code. I don't have to monitor what it's doing because it's doing a plan. So I'm waiting for it to finish the plan. And this is where I've started spawning multiple windows, multiple chats. And so at first it was code on the left, chat on the right. Now I've closed the code window and I had 2 chat windows. And then when I had 2 agents doing plan mode and I'd done the grill me and they were both just doing their job, I actually moved them up and then I had 4 windows. So now I have 4 agent windows, like a window, literally like a plus with 4 corners. And each one is doing a plan or executing or reviewing or learning. And I'm just going from chat to chat to chat to chat.
of the same code? Are you doing that?
Could be different code. So because it's in a single IDE, it's usually in the same code base that I'm doing something.
Yeah.
And because my team has a mono repo, so I'm kind of like the search API, I'm doing some PERL on the search API.
For me, it's multiple windows of cursor because each one is, I'm opening a workspace limited to, because I don't want it to accidentally pull in a bunch of context from a different repo.
It can though.
I know. Yeah. I've seen it do that for some of our bigger mono repos. But
you're doing 4 different tasks.
4 different tasks. And I'm not, so here's the thing is, I at first was isolated to the same code base before I realized your agent doesn't have to be in the code base that your IDE is in. What I do now is I open up my projects folder. I don't open my IDE in repo A, repo B. I open my global, like every single project I have installed on my machine. I open the IDE at that level and I'm looking at all the projects I've got downloaded from GitHub. I'll run I'll start a PERL from there and I'll point it at a subdirectory. Now I'm in the API. Now I'm in the worker. Now I'm in this. And this is, we talked about level 0 to 5. This is where those Amazon and Google engineers, level 6, level 7 through to level 9 is where you realize the level 7 up is basically where you realize your limitation is how much you can keep track of in your head. You're only limited by how many chats you can functionally be iterating through at a time. Well, yeah. There's other limitations. Yeah, for sure.
But like, because for me, when
Yeah.
Well, today I learned that Seamus knows how to use AI like a god, but still knows how to run late to a meeting.
Yeah. Yep. AI is not going to fix human problems, that's for sure. All right. Thanks everybody for listening. Hopefully this has been informative and enjoyable. Please use Pearl. It is helping me level up my game, and I would be very interested to hear how others are finding this process and what learnings they're getting from their review.